Good morning, Honors Chem fans. Mr. Sharp here with you doing a little lab demonstration. I've got my lab assistant back here. And what we are doing is part of the density lab is demonstrating. I'm going to demonstrate both the water and the ethanol portions of our density lab. And recall the learning target this week is density. Density is unique for every substance. Every substance in the world has its own unique density, and it also has its own unique density for whatever phase it's in, solid, liquid, gas. And so we're just going to collect some data here so you can do the analysis and enjoy the excitement. First thing, we have a graduated cylinder. Don't forget the reason it graduated, it passed my class. We want the basic, come on, settle down. We want its mass. So in the line that says mass of graduated cylinder, 21.05 grams. 21.05 grams. Never hurts to zero out. Do a double check. And again, we're 21.05 grams. We need that so as we get the mass of the graduated cylinder and water, we can back out the mass of the graduated cylinder. All right, our first, as I find my markings here, our first measurement then is with water at 10 milliliters. Just got to find my 10 milliliter mark. Check my meniscus. There we go, 10 milliliters. And we read 31.02 grams. Okay. Then we're going to kick her up to 20. At 20 milliliters. We are reading 41.35 grams. I can't write. 41.35, oh, 41.36. Make a choice. It's flipping back and forth. There we go, 41.36 grams at 20 milliliters. At 30 milliliters. 50.53 grams, 50.53 at 40 milliliters. $61.18. 61.18. And our last measurement at 50 milliliters. $70.93. 70.93. Okay, so that's our water data. You can then back out the mass of the graduated cylinder by itself and then calculate the density. Hopefully our values are consistent all the way through and my technique was done well. All right, we're gonna pause for a minute. Let me pause for a minute while I get the ethanol set up and then I'll be right back. All right, sports fans, we are back. My trusty assistant and I, we have a new liquid now in ethanol. This is part 3 of our density demonstration. So ethanol is the alcohol we're using. And again, I have a graduated cylinder, and this one also, it's a different one, but this one also passed my class. And really we're doing the same thing. And part of the connection here with the water in part 2 is that we see that while they're both liquids, they will have a different density. But again, first, let's start by getting the mass of the graduated cylinder itself, which is 20.82 grams. So the empty mass of the graduated cylinder is 20.82 grams. And again, let me just get my 10 milliliter mark. We are going to carefully pour into 10 milliliters. Slow and steady. Science is very exciting. There we go. The mass of 10 milliliters. 28.64 grams. 28.64 grams. All right, let's add another 10. Get ourselves up to 20. Okay. 20, 36. That worked well. 36.93 grams. 36.93 grams. All right, here we go with 30. $30, 44.68 grams. 44.68 grams. Let's go this way. 50, 40. We're up to 40. Well, 40 milliliters has a mass of 52.55 grams. And our last measurement is 50. 50 milliliters of ethanol. Has a mass of 60.74 grams. Okay, so now you have that data. And again, you can calculate the density with the grams and the volume. Don't forget to back out the empty graduated cylinder. And hopefully what we notice is that the density of the ethanol is not the same as the density of the water, although they're both liquids. Thanks for tuning in and watching this science moment. Have a great day. We will talk to you soon, Honors Chemistry. On behalf of my assistant and I, we look forward to showing you more lab excitement in the future. Talk to you later. Have a great day.